Ever feel like you blink and suddenly the AI that was cutting edge is already yesterday's news?
Yeah, it moves incredibly fast.
It really does. The speed of advancement in AI hardware is just, well, mind-boggling. So today we're going to try and make sense of the latest big leap. We're doing a deep dive into NVIDIA's brand new GB300 AI system. And to really get a handle on its significance, we'll be comparing it back to their previous flagship, the GB200, and also the Hopper architecture, the H100, which is still everywhere.
Right, the H100 is still workhorse.
Exactly. So we've waded through the technical specs, the industry news, expert analyses, the usual stuff. Our mission here is to pull out the core insights. What are the real performance jumps with the GB300? What could this mean for the future of AI computing? And hopefully do it without getting totally lost in the jargon.
Sounds good. Where should we start?
Okay, let's unpack this. Maybe start with the overall performance leap.
Yeah, definitely. What immediately stands out is just the magnitude of the performance jump. Our sources are pointing to something like a 1.5 times increase in AI compute power compared to the GB200 NVL72, which is already impressive.
1.5 times is pretty significant on its own.
It is, but the difference is even more stark when you compare it back to Hopper, the H100. We're seeing claims of like a 10-fold improvement in something called user responsiveness.
10 times.
10 times. And also a 5-fold increase in throughput per megawatt, basically how much work you get done for the energy you put in.
Okay, hold on. 10 times more responsive and 5 times more energy efficient than the H100. That sounds like a massive difference.
It really is.
So practically speaking, what does that actually unlock? What kind of new AI stuff could this enable?
Well, if you think about the big picture, running these really complex AI models, especially for things like reasoning or, generating content, this could translate to maybe a 50-fold increase in the overall output of what you might call an AI factory. Yeah, 50. Think of it like this. A data center that's handling a certain amount of complex AI work right now with H100s could theoretically manage 50 times that workload just by swapping in GB300s.
Wow.
That kind of scale-up could have, profound implications, maybe enabling real-time analysis of huge multimodal data sets for, drug discovery or climate modeling, things on a scale we just haven't seen.
Okay, so the raw compute power is clearly a major step up. But these big AI models, they chew through enormous amounts of data, right?
Yeah.
How does the GB300 handle the memory side, the data processing?
Yeah, that's a critical piece of the puzzle, how these systems actually process information. The GB300, and specifically the Blackwell Ultra GPUs inside it, gets a really significant memory upgrade. We've gone from 192 gigabytes of HBM2E memory in the GB200 to 288 gigabytes of the newer, faster HBM3E in the GB300.
That's quite a jump, 288 gigs.
It is. And this larger, faster memory capacity is just essential for working with these increasingly huge and complex AI models. It lets the system keep more data right next to the processors and access it way faster. It's sort of like giving a mathematician a much bigger, faster notepad right beside them so they can juggle more complex stuff at once.
That analogy helps, yeah. More high-speed memory means the AI can work with bigger problems more efficiently. Now, with all that processing and data flying around, the connections within the system must become super important. What about networking? Any advances there?
Oh, definitely. Networking can absolutely be a bottleneck if you don't get it right. And the GB300 makes some pretty big strides here. It uses upgraded Connect X8 Super NIOX.
Super nice, right.
And supports optical module speeds up to 1.6 terabits per second.
1.6 Tbps, how does that compare?
Well, basically it doubles the network bandwidth compared to the GB200.
Well, doubles it, okay.
Yeah. And in these huge AI clusters, where you have tons of processors all working together, that high-speed, low-latency communication is just vital.
Yeah.
It stops things from getting jammed up and makes sure all that processing power can actually be used effectively. Think of it like upgrading from, say, a 2-lane road to a 4-lane superhighway for data.
Faster processing, more memory, faster connections. It really sounds like the GB300 is built for seriously demanding AI work. Our sources mention it's good for both training models and using them in the real-world inference. Can you expand a bit on the inference side, especially for those complex reasoning tasks?
Absolutely. The GB300 seems specifically designed to really excel at large-scale inference. That's where you take a trained AI model and put it to work, making predictions or giving responses in actual applications.
Right.
The combination of more memory and more compute power lets the GB300 handle much longer context windows.
Longer context. What does that mean practically?
It means the AI can keep track of and process way more information when it's making a decision or generating a response. Think about advanced chatbots that need to remember the whole conversation, not just the last sentence, or processing really long, complex documents.
Okay, gotcha.
Plus, the speed it can process language models gets a huge boost, reportedly up to 1,000 tokens per second.
1,000 tokens a second, that sounds fast.
It's a tenfold increase over the H100.
Right.
And that translates directly to much faster response times, a more fluid user experience when you're interacting with AI.
Yeah, imagine asking a really complex, multi-part question and getting a full answer back almost instantly. That would change things.
Exactly.
Okay, let's maybe dig into some of the specific numbers our sources laid out. There's often a table comparing these things.
Yeah, the spec comparisons are useful.
So looking at the GB200 NVL72 versus the GB300 NVL72, we've hit the memory increase, the 192 GB to 288 GB HBM3E. What about this FP4 compute figure? It goes from about 0.7 exaflops to 1.1 exaflops at the system level. What is FP4?
Right, so FP4 is a very low precision number format. Think of it as a way to represent numbers using fewer bits. It's super efficient for certain AI calculations, especially during inference. So that jump from 0.7 to 1.1 exaflops, even though exaflops sounds like this huge abstract number of billion calculations per second, it basically means that the system can do a lot more of that core AI math much faster.
More core math, faster. Got it.
Which helps speed up both training and significantly inference.
And then there's NVLink bandwidth. The table shows it going from just lower on the GB200 spec sheet we saw to a specific 130 TBs on the GB300. That seems like a massive internal highway upgrade.
It is. NVLink is NVIDIA's own tech for connecting GPUs together really fast within a single server or node. Boosting that to 130 terabytes per second means data can just flow much more freely and quickly between all the connected GPUs.
Crucial for big models spread across GPUs, right? Absolutely essential. For training those massive models that don't fit on one chip, and for complex inference tasks where the GPUs need to coordinate constantly, the previous generation definitely had some limits there that this seems to address.
Okay. And we mentioned the network bandwidth doubling to 1.6 TBPs. The table also repeats those responsiveness and throughput figures, the 10x and 5x improvements over H100, and that potential 50x AI factory output jump.
Yeah.
But then there's power. Individual GPU power draw goes up. Roughly 1,000 watts to 1,400 watts. Is that increase a worry?
Well, it's definitely something data centers have to plan for. More power means more heat to manage. But the key thing that the sources emphasize is that big improvement in throughput per megawatt.
Ah, right, the efficiency.
Exactly. So yes, each GB300 GPU uses more power than the older ones, but it gets significantly more AI work done for each watt it consumes. That improved efficiency is really crucial for managing running costs and, the environmental footprint of these huge AI data centers.
So it's using more power individually, but doing way more work with it, making the whole operation more efficient overall. That seems to be the idea, yeah.
Okay, shifting gears a bit from the chip itself, what about the actual systems built around the GB300? The physical stuff, the infrastructure?
Yeah, they've definitely thought about the whole system. The GB300 platform introduces some pretty significant infrastructure level things. One big one is a fully liquid-cooled, rack-scale design.
Liquid cooling seems almost necessary at this point.
It really is becoming vital. Managing the heat from these incredibly dense, powerful processors is a major challenge. Liquid cooling helps keep things stable. Plus, they're integrating things like battery backup units, BBUs, and supercapacitors right into the rack design.
Oh, interesting. Why?
It's all about reliability. Preventing data loss or disruptions during power fluctuations or brief outages, which can be a huge issue in massive data centers. It adds a layer of stability.
Makes sense. And modular design.
Yeah, the modular aspect is important too. It allows for more flexibility, letting customers configure systems more specifically for their particular needs, rather than a one-size-fits-all approach.
Okay, so it sounds like a really comprehensive upgrade chip, memory, network, power cooling, the whole package. However, one of our sources did suggest that maybe the initial market uptake, the adoption of the GB300, might be a bit measured, a bit slower. Why would that be, given how impressive it sounds?
Yeah, that's a really important point to consider. It's the classic cutting edge versus practical reality situation. While the tech leaps in the GB300 are substantial, deploying this stuff at scale isn't trivial. Think about it. Huge amounts of existing AI infrastructure are built around the GB200 or even the H100. That stuff is established, people know how to run it.
Right, there's inertia and expertise.
Exactly. Switching to a new architecture like the GB300 means significant upfront costs, retraining people, integrating it smoothly with everything else. So even with clearly superior tech, there can be a natural, maybe hesitation, or at least a careful evaluation period before companies dive in headfirst and rip and replace everything, especially in these big, expensive data center environments.
That makes a lot of sense. The raw power is one thing, but actually deploying and managing thousands of these things is a whole different challenge. Okay, so to try and wrap this up then, what are the main takeaways here about the NVIDIA GB300?
Well, I think the bottom line is the GB300 really does represent a significant leap forward in what AI hardware can do. Compared to its predecessors, especially Hopper, it offers really substantial gains in user responsiveness, raw processing power, memory capacity and speed, and network bandwidth. These improvements kind of pave the way for tackling much larger, much more complex AI models than before, and for enabling real-time AI applications at a scale we haven't really seen yet.
So it's not just a small step up, it feels like a fundamental shift in the potential of AI infrastructure, even if, as you said, getting it widely deployed might take a little time.
Precisely. It really sets a new bar for AI performance and the kind of infrastructure needed, setting the stage for whatever comes next in AI applications.
Which leads to the final thought, maybe for you, the listener. With this kind of jump in the capability, what entirely new AI applications do you think might actually become practical now? And on the flip side, what hurdles, maybe beyond just cost, do you think might still slow down getting them everywhere? Definitely something to chew on as this field keeps charging ahead. Thanks for breaking all that down today.
Yeah, fascinating stuff. Glad to talk it through.